All right. Okay. I'll just dive right in. We are in sort of in the midst of year 4. So our original goal after the budget cut was to phenotype 1,280 animals. We're at about in the 900s now, of which 730 have been sent to UCSD, 585 are genotyped. There's, just to recap, there's 5 basic behaviors, 3 of which are aversion related because of our sort of hunch that there's aversive influences on addictive behaviors that are somewhat less well understood. Just to recap, the first one of them is this cocaine runway task that Attenberg used for a couple of decades. If you have animals traverse a 5-foot corridor to receive cocaine, you get a number of animals that run very quickly to the end of the 5-foot corridor, but some of them develop these longer and longer latencies to, can you see my cursor? They develop longer and longer latencies to obtain cocaine. We call these high avoiders. The reason you don't see this in a traditional self-administration paradigm is that this runway task is run with kind of low levels of low rates of reinforcement. The trials are separated by several hours, so this tends to exaggerate the aversive effect. We do this because we think it mimics kind of the early stages of drug vulnerability when you're still sampling the drug. You don't have access to infinite piles of it, you're just taking it and sampling it. And people who have immediate aversive effects, reactions, tend not to as quickly progress on to habitual use. We see it looks very similar in Sprague-Dawley and HS rats. The only difference being Sprague-Dawley's on the top, there's a bimodal distribution of latencies with low avoiders and high avoiders. And the HS's, you see a big bump on the low avoiders on the left side. Is my cursor showing up?
Yeah.
Okay, but you don't see that second bump on the low high avoiders. You just see this long tail. But otherwise, it's very similar. There's massive individual difference in the latency on this runway task. We do a number of other tasks that were originally meant as control tasks, but they are kind of important for addiction in their own right. Of course, there's punished food seeking. So we basically have animals press a lever to get a food pellet and a foot shock simultaneously. The shock intensity escalates about 25% every 3 trials. And then when they stop pressing, we call that a break point. So it's very analogous to progressive ratio. We have a version of this in which we delay the shock by 40 seconds. And the reason for this is this is kind of key to addictive behaviors where the reward is immediate and then the cost comes somewhat later. So we often think about addictive behaviors as being reward seeking in spite of negative consequences. That's sort of half the story because a lot of productive behaviors also have rewards and negative consequences, but typically the temporal order is reversed. If the reward is immediate and the costs are later, that's bad. If the costs are up front and then you have a reward at the end, we tend to think that of as a good thing. And so when we've now analyzed our 900 plus animals, the behaviors are surprisingly independent of each other. There's kind of 5 categories, and we have multiple measures within each category. The measures within a category correlate well with each other, and measures between categories pretty much not at all. I'm surprised at how little. I was expecting some mild correlations, but they're pretty independent. There's been a few mentions of whether or not there are sex differences in delay discounting type tasks. We see pretty reliable sex difference when you delay the punisher. All animals take more shock if you delay it. Males take about twice as much, females take about 2.7 times as much. And this is pretty consistent across many cohorts. So I just thought that was interesting. As I mentioned, we have 585 genotype animals. This is a heritability matrix on the left side, heat map. Brighter dots are more related. The SNP heritabilities are in the 0.2 to 0.4 range for most behaviors. I'll talk a little more about that in a minute. So not super high, not super low. We don't yet have any significant hits. There's one dot that's just knocking at the door of significance, but nothing yet has broken the threshold. I hope with the next group we will. The cocaine runway task is the one for which we have the most independent evidence of heritability. And this heritability is somewhat disappointing. We were expecting about 0.4 based on our selective breeding tests. It's closer to teens. One thing we've noticed when we started looking at the data more carefully, so my techs have been telling me for a couple of years now that the males are fussy. Some of them, a significant subset of them, don't want to do this task. They just sit in the start box and don't traverse the 5-foot corridor. And this is apparent even before you start giving them the cocaine. They are slow to habituate. We run a few habituation sessions with no cocaine. You just put them on the apparatus and let them run around. And we noticed the males are consistently slower to do that. They take longer to reach the end of the corridor. And there's one, you notice I've broken it down by the handler that was handling the animals. So there's 4 techs that ran this, or 3 techs plus Maya, who is an MD PhD student. Maya ran about 500 of the rats we've had so far. So the males are generally slower. And we had noticed that one particular tech had particularly slow habituations. This was Alexa, who was with us for about 4 months, 2 years ago. And we were puzzled by that until recently. A new tech came to the lab, Mitchell, and his habituations are just the worst we've ever seen. And we were trying to think, well, what's common between Alexa and Mitchell? And turns out they both own cats. And this is a task where the lid of the apparatus is open to the rest of the room, unlike our others. And so I'm kind of thinking that this is affecting things. Fortunately, only about 10% of the animals were run by those 2. The other 3 ran the other 90%. So we can exclude those. What we find is that when we do that, the heritability more than doubles. It ends up at about 0.4 if we exclude their animals and especially exclude the males. So it's somewhat bothersome that we have to do this because the ends are low and we are basically now switching to just running females to try to catch up so that we have enough to get the power that we need. So going forward, we're a few months behind in the phenotyping, and so we've added some more apparatuses to speed up the runway testing. We're testing exclusively females now, where we see higher H-squareds. We're only having techs that don't own cats run the tests. I don't know if we should drop the progressive ratio test. The heritability is 0.04. And it's, I don't know if we're ever going to get anything out of that. That will sort of help us catch up a little bit. I don't know if anybody on the call has thoughts about things like that. Yep, and we've got some RNA-seq that we're just starting to do, but we don't have any results on that yet. So I'm done.
That was terrific. And Tom, you're, I think, the first speaker, certainly in this session, to actually stop before your time was over. So we could have a little bit of conversation here. The next speaker is going to be Jessica, speaking for Francesca Talise, who's on maternity leave. And
how did you figure out the cat thing?
All right, Tom, how did you figure out the cat thing?
Well, I don't know that that's it. We just asked, we just sat down and brainstormed with everybody in the room and tried to figure out what was different, because there's this well-known study that that rats respond differently to males and females being handled by men and women, and that wasn't it. Because Alexa is female and Mitchell is male, and so at some point somebody realized that both of them live with cats, and we've it's quite well documented that cat odors are aversive to, there's lots of fear conditioning studies on that. So I don't know for sure that that's it, but it's clear that the animals know who's handling them. they're consistent differences. It's both disturbing. It's both interesting and disturbing.
So can you do something, do you think, about the cats, like wearing or taking a shower? Or
Yeah, we've tried all of that. No, we just yeah, we had somebody we had somebody wear scrubs. No, it doesn't seem to help. So they seem to know who's who, and we've had individual animals run by two different people, and they respond differently to different people. So we're just having it's somewhat inconvenient because it restricts who can run this particular task.
Yeah, the people.
Our Invisibilia episode about this, how they
About
did a
cats?
study,
Yeah.
how they did a study and how the rats respond differently because the handlers treat them different, even if it's
Yeah.
subconsciously.
Right. Yeah, I mean, you could randomly assign cats to some of your handlers and it's replicable.
Yeah.
Right
So,
now, it's
yeah.
pretty confounded because the people who choose to have cats might be different kinds of people. I would
Yeah.
argue nicer people, but who knows?
The rats just don't want to run away from them.
That's right. Maybe that's it.
Were the
Okay,
cats males or females?
That's a good question. I don't know. I'll ask.
Raises a whole other dimension of question.
Like I said, I don't know for sure that that's it, but with an N of 5, there's a perfect correlation. The 3 people without cats are fine and the 2 with them are not.